Alright, hello everyone. So this is me attempting to speedrun something, just for the meme basically. Um, Both my brother and a modder friend decided to, they have a need for generating the terrain in Unity through code. So I'm going to figure out how to do that, and I'm going to try and speedrun it. And I have done it before, but it's been a few years. So the plan is, let's just like write something here. Basically, you have a point which we'll call 50-50, and then you basically build a grid like so, and then you can copy these. You basically build the grid up, and then all you need after you have this mesh function is some type of input generation, and what we're just going to use is sin, because why not, or sin times like not 2. Oh, that'd be the height, and then you'll have the frequency in here. Alrighty, so let's try and code this up. I haven't done a single thing yet. I haven't experimented, haven't done anything at all. So I'm gonna have to open Unity when it gets there. Okay, we got a Unity hub. Let us start a new project. So I have to drag it onto my second screen here. I have a 3D project. We will just call it terrain test, something like that. In projects, create. And come on, Unity. What did you just do? There it is. It's starting up in the other screen. Silence. Okay, come on. I wonder if I can move this to the other. Yeah, there you go. So you can see it's starting there. And here we go. So, a Unity scene. This is just going to be our test scene. We have the camera and the light. That's fine. So what we want to do basically is we want to create planes, and then we're going to come over here and create a new plane. But we want to do this through code so that they tile. So we actually don't need these planes. What we need... Oh, actually it is worth noting what they have. They have a plane, mesh renderer, and a mesh collider. Okay, that's fine. But we will need to create these through code later. So we can just delete that. What we will want is an empty so that we can create a script on it. So we'll put this like program code. We'll create a new script called something. Not new behavior. As you can see, I haven't used Unity, so here we go, rename. Let's call this terrain gen. Why not? Nice and simple. And because it's a mono behavior, we want to add it to an empty so it'll actually run. Can we just like drag and drop it? Oh, here we go. Do I have to call it .cs? What the hell? It's a mono behavior. Oh, yeah, okay. I can see. It's not called terrain gen because I didn't name it properly at the start there. Alright, so now we can just drag and drop it, hopefully, onto our program code. Okay. Did I accidentally... Didn't drop that onto something else, did I? Nope. Okay, there we go. So we got one of our terrain gens. We'll just do our hello world. So console... Oh, actually, no, it's debug.log in Unity. Log. Why don't I have... I don't have Visual Studio set up for this. So I need to go to my preferences. I need to use global mono because I'm working with framework, and for some reason this is a bug on Linux. So, oh, that's right. Oh, I don't have the Unity debug stuff. Oh, that's a massive pain. I think there is actually a Unity debugger, isn't there? I just may not have it installed. Yeah, debugger for Unity, I need this. And it's installed. Alright. Ah, you're gonna see me struggle. Yeah, the Unity debugger, it is there. Okay. So now we have our debugger. Why isn't... Oh, there we go. So now that I changed that thing before, we got our Unity methods. So we'll just do our hello world. I'm so used to building in Visual Studio. It hurts. It really hurts to just press play in Unity. It's so much slower than just running the code. And we should see in our console, hello world. There we are. It's fine with that. Alright, so now we can just code our stuff. Can I clear this? So I know that I haven't got errors. There we go, clear on play. That'll do. So we're going to need to keep some state around. So to do that, we will have a game object. Let's say, actually no, we're going to have a collection of objects. How do we want to index them? I guess that's the question. So what I mean by that is if we have these planes, right? They were like this. I think it makes sense to just reference. We'll put the transform in the center. Makes things easy. And then we'll just call this one like 0, 0, 0, 1, 1, 1, and 1, 0 for the x and the y coordinates. Well, x and z on Unity, I guess. I think that'll be fine. So we'll just do that. So dictionary. We want to index by, how do we want to index? Because we need to map that to something. I guess for now, we'll think about that later. We'll just make a list of game objects. Goes, whatever. So when we start, let's just initialize them all straight away. Let's make 5 of them, let's say. So for int I equals 0, I is smaller than, sorry, I'm fighting my IDE here. I plus plus. Okay, alright, so we've got a loop that runs 5 times. We will go goes dot add game object geo equals new game object. Go. Add component. So we need a mesh renderer. Because we're only wanting to display mesh renderer and mesh filters enough. I don't know if these have to be done in order. Mesh filter equals MF. There we go. So I believe these need to be in order, and I'm pretty sure you go mr.mesh or something. I don't care about the material. To check this, what we can do, you can see an error there. I really wish I could just build this. Actually, can I just build this? Can I just build it with MS Build? I don't think so. No, there's no solution file. Is it possible to generate a solution file? I don't think so. Alright, I think we're just going to have to stick with Unity. That's kind of annoying. So we can just delete their, I don't know what that settings to JSON is. I haven't seen that before. Our task has to go. And for launch, I think we just, Unity editor. Yeah, that's fine. Alright, okay. So, what can we do here? So we have our 5 objects created, so we need to actually check how they're built. So let's build a plane again, because this is going to be our base object. So these are the things we can set. So when mesh collider.mesh equals plane, and the mesh renderer does not take a mesh. No, the mesh renderer must just read the mesh collider itself, so we don't have to do anything here. So let's create a mesh. So what the hell does a mesh have? M equals what? What do you have? Whatever. Let's just see what the thingos are. Colors, I don't care about. Normals, don't think we care about. Triangles, we definitely care about. Oh, it's triangles and vertices, almost certainly. There it is. Okay. So let's we need a function that generates a mesh. So mesh generate mesh. Nope. Oh, I'm fighting my IDE more than I'm actually coding. Alright, so instead of this new mesh, what we're doing is generate mesh. Our mesh filter dot mesh equals to m. Is there like an apply or an update? I remember there being something that we had to do. I guess we'll figure that out in a second. And probably makes sense to only have one of these just for now. So obviously we're going to have to return a mesh. So mesh return val equals new. You can call this like temporary variable, whatever. I just go with retval every single time. Return a retval. Alright, so we will get some type of mesh there, but that's not going to be very helpful. So retval. Let's just make a square. So that'll have a point at the 0, 0, 1, 1, 1, and 1, 0. And it'll also have 4 vertices, and it'll have 2 triangles because I guess I'm going to have to draw this. No, console. Where are we? Color paint. So basically, we're going to expand this out. This will be 0, 0, 0, 1. Actually, that's the x coordinate. And 1, 1. And then you either have a choice. So when you draw these triangles, because the game draws in triangles, you can either go this way or you can go that way. It doesn't really matter. As long as, you know, we've got some type of system to draw these triangles, it's fine. Alright, so retval.vertex count will equal, oh, okay. Gets set from a vector 3. Okay, so we need to generate a vector 3 array. Vector 3 array. Verts will equal new vector 3 array, and whoop. Obviously we'll have 4 of them because we're making a fucking square. And triangles we will have 2. I think this is an int array of something times 3. Just the index of the vertices. Int array, I think so. It's obviously 3 times 2, which is 6, but we'll just do that to make it obvious. So verts 0 is going to equal to new vector 3. I'm pretty sure Unity uses y as the up and down direction, and we want to go like on a flat plane. So we're going to be using x and z. Alright, so let's just have some type of numbering system for these points. So color paint again. So I'm going to go probably start index here and then do 1, 2, 1, 2, 3. I think this way makes sense. And then this way will be 10th vertex and 20th vertex and the 30th. This will be wrong, but only slightly. I'll come back to that. So our next vertex is along the x-axis, and then it's x0, y1, and then it's 1, 1. These are also floats, but I guess they cast, so it doesn't matter. And our triangles, I'm going to have to draw in groups of 3. So 0 equals 0. Oh my god, my IDE. Sometimes they're a little bit too helpful, you know? So we have 6 points in the triangle. So what we'll do is 0, 1, 2. 0, 1, 2. And then we'll go to... I think they have to have a rotation. I think you going clockwise or counterclockwise as long as you go the same direction. I think this matters. So then we'll go 2, 3, 1. So then we build a... Actually, does the mesh have a constructor that takes... No, it does not. Oh, okay, that's helpful. Alright then. Unity. You could have given us a constructor, you know. Alright. So retval dot vertices equals verts. Retval dot triangles. Oh, hang on, there's a set triangles function. I'm going to assume Unity does something special, so I'm going to call that. And I'm going to assume that there's also a set vertices. Yes, there is. Vertice. And I think there's something like optimize mesh. Yeah, whatever. Not that this can really be optimized, it's like 4 triangles. I mean, 4 vertices and 2 triangles. Set what? Sorry about that. Submesh? What the hell is a submesh? I'm just going to assume 0. Whatever. I could look that up, but I don't care. So, generate mesh. Will this render now? So, we better give this a name as well. Go.name. Just so we can tell what this is. So this is a plane, and we'll call it I. I love string interpolation now. String interpolation is love. String interpolation is life. Alright. Let's try and build this now. So we'll get rid of our original plane. Come on, Unity. What are you doing? Are you compiling? Yes, you are. Okay. I'm so used to that taking like half a second. So there we go, plane 0. So we have something. Where is it? It's at 0, 0, 0. But I didn't see it, so there's obviously a problem that we have to fix. Just so that we can check, if we're at 0, 0, 0, can we actually see a plane? Yes, we can. So we should be seeing that. It's possible that the triangles are upside down. So that's probably the first check, because the triangles have a certain direction depending on which way they're drawn. It could be clockwise, it could be anti-clockwise. So we'll just flip these numbers around. So now we're drawing the triangle backwards. So from 0 to 1, so drawing it clockwise now. And 2, 4, 3, rather than anti-clockwise, which is 0, 1, 2. Alright, and do we see it? Compiling. Oh yeah, some indices are out of bounds, index count 6. What? Okay, well that'll probably be a problem. Failed setting triangles, referencing out of bounds vertices. Oh, because it's... I'm an idiot. There is no 4th triangle. So 0, 1, 2, 3. So 0, 2, 1. And then... I think... So we're drawing clockwise. 0, 2, 1. I think you start off with this vertex again. So that helps. And then do 1, 2, 3. Okay. Now that shouldn't be out of bounds. Also, it would be really handy to have a debugger. I need to need to attach that. All right. Hey, well, we see something. That is a start. It doesn't have a material. I think that's why it's that pink color. And also, it would be nice to... How wide is a plane? Because I just did about 1. So if we go 0, 0, 0. Let's look at the origin here. So let's go back somewhere like here. So let's set the camera to this. So main camera, align with view. Align with view. Okay, so now the camera's looking at the square, like that. Because we don't have a way of controlling it yet. So delete that now. Run it again. There we go, so we can actually see it a little bit better. It's tiny, but that's not a problem. I guess Unity's plane is just bigger. Maybe our square's only like 1 of those, and this might be 10. We can check that. So let's go to program code. Where are we? Program code. Terrain gen. Why are we... There it is. So I'm assuming that Unity, the vectors are probably -5, 5. Oh, hang on, this would be -5, -5. So let's just assume that they're 10 big. So 0, and then we go across in the X, and then this will be the same like that. Now let's draw that. Hate how long this takes to compile. This is just like a single script. Yeah, there we go. That looks a little bit more familiar. So that's obviously Unity being 10 units instead of 1 unit, because, you know, that makes sense. So what we want to do now is probably give this a material. Can we just like... I think... Okay, I probably need to look this up. I'm not exactly sure how to generate a material from scratch. Oh wait, hang on. Isn't there like different shaders that Unity has? Isn't it just like shader dot something or other? Alright, because I can't be bothered, we'll just do this for Unity for now. So we'll create a shader. Create a material, I guess. It's probably in here. There it is, material. We will call this... How do we call this? Yeah, standard shader. I don't know how to get this pragmatically. There's probably a way to do it, and it probably would make sense for me to figure out, but for now I can just worry about that later. So let's make this a nice... I don't know. Let's go for blue. Looks horrible, but that'll do. It's metallic too. Okay, no, it's just me messing around. Alright. We shall call this material test mat. I guess this really isn't what I care about. I only care about generating the mesh. As for coloring it and stuff, that's a different video, I guess, but not for me. So go look at someone else's material. So we will... I think we can just find the material. So test mat equals material dot find. Can we... string contents. Oh, hang on. How about we just do this properly? We'll do it through code rather than generating that material. I'm pretty sure all we need to do is, I've got no idea how to do this, but let's use DuckDuckGo. Unity shader, find shader, something like that. Shader.find. That's probably it. Yeah, this is exactly what we want. Alright, we shall copy pasta. Except for we don't want transparent diffuse, I can guarantee that. Let's go testnet. I think it's just standard. And then material.color equals blue. And this is probably a mesh renderer component. Yeah, I don't think that really cares. Okay, alright. So we shall delete this material. Oh, is it not going to let me because I have that open? And now it'll compile. Delete. Can it call get lost? I think this is just Unity bugs, not my bugs. Yeah, there we go. We have a plane that's pragmatically generated with code with a material. So we're getting close. So let's create 5 of them. So we shall do 5. Plane generate mesh filter. Okay, I think this is all good. But what we do want to do is game object dot I guess the position. How about instead of these being 5 big, we just, you know, keep them 1 big, which would be, if they were 1 big, then I guess they'd go from -half to half. I think this is complaining about casting to float. Yeah, okay, Unity loves floats, so these will have to have F's after them. Because, you know, doubles, they're scary for Unity. Just for those who don't know, double is like 64 bits wide, and a float's only 32 bits wide. I guess these are also floats, but I don't think it matters because they're all 0. What we're going to do eventually is have a function that generates these y heights, but that can come later. So go dot transform, because we want to move the bloody thing, dot position dot x is equal to I. I think that's all we need to do. Why can I not transform? It's not a variable. Okay, so I have to give it a new transform. Equals new. It's almost certainly a vector 3, right? Yeah, it's a vector 3. I can do that. So we want to move in the x direction. I 0? 0? Yeah, that'll do. I think we're good there. So we should see a thin line 5 length by 1. So it'll be smaller because there's only 1 of these. My triangles are messed up because I'm drawing them the wrong way. That's interesting. It's very interesting. Wouldn't have expected that, but I guess I must be drawing one backwards. So what we can do to test which one it is, comment out that, and then just go, there's only one triangle now. So let's build that. Now if we got it right, we will see exactly the same thing. If we got it wrong, we'll see nothing. Come on. We see nothing, so we got it wrong. So it's the first triangle that's wrong. So why is that wrong, actually? Oh, hang on. No, it's not wrong. I had this wrong. So now it should be right. Sorry, I wasn't drawing backwards because we proved that before because the triangle's right. It was because I put the vertex in the wrong spot. So let's build it now. Hello? Oh, out of bounds. I didn't change the 3 back to a 6, did I? No, I did not. Alright. You can cringe it 3 times too, all you like, but it'll come in handy later. There we go. That's exactly what we want. So now we can generate a plane. So these are 5 objects like stacked next to each other. We have the option of creating either heaps of game objects, or we can just make one game object bigger. And I think I want to go for... Oh, do we want to keep our code simple or not? That is the question. I think I would rather have a bigger mesh and fewer game objects than fewer game objects and a bigger mesh. Well, whatever. We'll just... More vertices. So, what we have to come up with is a way of generating this now. So, for int equals 0, I is smaller than, let's go for 100. I plus plus. So, we still want to have this minimum and maximum as -half and half. So what we want to do is we want to get like a percent. So double scale equals, oh, let's go x scale, something like that, is equal to I divided by 100f, because we don't want to use integer division, otherwise we'll just have a whole heap of zeros. We want to, you know, actually increase. And we will do the same for the y value. Actually, you know what? Instead of calling this I and j, should we call this x? Probably looks a little bit cleaner this way. And I have left a mistake in here. You don't know if you can see it yet. I kind of want to show off the mistake first, just so that you, if you run into this, which you almost certainly will when creating this. So we can actually move this in. Actually, that can stay out there. So now this will be a y. So our vertices, we need some type of indexing. I guess, what's an easy way to index this? We'll do the easy thing first. So, because this is... maybe I should... No, I'm not going to preempt it. I already know what's going to happen. So... oh, hang on. No, what are we doing? We don't need to index. We just keep it. So we will create 6 vertices. At new vector 3. So it's 0.5f. You know what? Also, actually, this is not Y, this is Z because of Unity convention. That's actually going to keep messing me up. I'm so used to 3D printing where the x-axis is up and down. X scale, and this should now be x scale. Let's see scale. All right. It's not a double. I'm used to using doubles as well. God damn it, Unity. You can tell I'm not used to it at all. Okay, so that's one vertex at 0 to 1, but we want to shift it. We want to shift it like that, I believe. Like so. And that's a one vertex. Oh, now I understand why people use lists. Hey, you know what, guys? Let's just be lazy. We can just use lists. No, can we? No, we're not going to use lists. We don't need to. Alright, so... Yep. So we're going to have 4 points. No, we're not going to have 4 points. We're going to have 1 point, aren't we? No, you know what? No, we will have 4 points. Will we? Need to think about this for a sec. Because we need to index still. My plan was to do this. So we're going to generate 4 vertices at a time, and then draw the triangles with them. So current try, I guess. Equals current vertex. Plus 2. Plus 3. Plus 4. And plus 5. So we go 0, 1. Oh wait, hang on. Clockwise, isn't it? 2, 1. Oh, let me stop here. And then we go from the first vertex 1, 2, 3. So current vertex plus is equals to 4, and current try plus is equal to 6. So now, if we have 100, oh, I have to do this. X total equals to 100, and Y total equals 100. X total, Y total. Oh, it's not Y. Oh, wow. Alright, come on. Z total. There we go. I kind of wish that I could show this in more steps so you could understand what I'm actually doing, but yeah, whatever. So by C total, X total float. So get rid of our 100. C total. Oh, I so want to compile it inside the compiler. Alrighty. Now, the problem is how long are these arrays? So we will have to calculate that, which is actually not too hard. So 100, 100. So we're obviously going to have X total by Y total, Z total by 4 vertices. And for triangles, we should have X total times Y, Z total times 6, I believe. Just to check that, I think we can set a breakpoint. Oh, you know what? It should error out if it's wrong. Now, can I just run this? I'm expecting to see a problem, but... Oh, will I see a problem? Because this might actually be scaled differently. No, I think it's good actually. It might actually be fine. Alright, let's just give it a run. Hopefully we see the same thing. We see nothing. Index out of bounds. Alright. Now, it would be really nice to actually run the debugger. So, how on earth do you do that in Unity? I think I need to look this up. So, something like this. I know about attach to Unity. That's just this button here. Oh, do you do it while it's actually... Hang on. Do you have the script open? Then you have to do attach. Can we just attach it now? Attach. Yes, we can. Okay, thank God for that. So what we want to do is we should see an exception. So if we try and run this, it should go index out of bounds. No, it did not. Thank you, Unity. You're wonderful. How about we set a breakpoint? So let's go here. Once we have our breakpoint, then we're in familiar territory. Yes, we do. Thank God. So our current vertex. 4. Did we already go through one of these? Yeah, we already have 4, 5, 6, 7. So let's go to the end of here. So that's the second one. So let's go back to here. So we're on to 100 now. What am I missing here? 100 times 100 times 4, 100 times 100 by 6, 1, 2, 3, 5, 6. How does it error? Yeah, okay. Unity isn't catching my exception. That is really annoying. So I guess I'm gonna have to catch it myself. Someone more experienced than me is probably like, yeah, I can see it already. Obviously the index, this array size is just wrong. I know that for sure. But I don't know why it's wrong. Let's just do some debugging. So because I won't know the value of these xz's during the exception, I'm going to have to just set them manually. So last x equals to x. Whatever, we're just going to call it y. Get used to it. Debug.log error. Oh my god, I do not miss debugging like this. I can't believe that this is a problem at all. Like, why is it out of bounds? Alright. We might need to detach the debugger, and then we might need to let Unity do its thing. Okay, so now we attach again. We run. And we have our error, okay. Which is at 99.99. I thought I wasn't running inclusive. Do I need to add 1 to this? Alright, sorry about that. Okay, so at 99.99, which is correct, that's the very last one, it errors. So if I have, oh, yeah, it is +1. I guess. Now hang on. I'm going crazy. I'm going crazy. I just need to prove something to myself. So if we've got Oh, I am regenerating a lot of these triangles because I'm putting a lot of copied vertices in. Um, Perhaps I'm generating this incorrectly because if I just need to think about it, I'll do a 4x4. I'll only start drawing here. I could be using a lot of these vertices over and over again. So 0, 1, 2, 3, and this is obviously the length, so that's 4. So just to generate the sequence, I should probably do it like this. I think the vertices is correct. Could it be? So it'll be clockwise, so it'll be 0, 4, 1, then 1, 4, 5. Then the next one would be 1, 5, 2, 2, 5, 6. Should probably generate it like this. So every time we add a triangle, yeah, I'm doing it wrong for sure. Alright, so now that I've started off with this, what I want to do, we'll just create one vertex per xz, sorry, rather than 4 of them. So that's okay. So let's get rid of this try catch again. Get rid of this. So we'll just build the dots first. And then we'll go and build our triangles. No, that's right, I can't compile. Alright. Let's get rid of Unity. Stop. Alright. Let's not. Come on, stop. I want a debugger. Let's go to here. So let's attach our debugger. There you go. Now, vertices should look pretty sane. So we should have a lot. That is definitely incorrect. Okay. Interesting, interesting. Why? Oh, because we just set the one vertex. We actually don't need to keep track of that, because that is just going to be Z. Z was like up and down, so we'll use this as the times x length plus x And I'm pretty sure that's the way to index correctly. And where's our debugger? Can we just leave this attached? Yes, we can. Alright, that makes things easier. Now if we look at our vertices, they're probably generated correctly. Why there is a heap of them? Yeah, okay, so it starts off from -5, goes all the way to +5. Alright, then the next one will be the next row. -5, -4, that should be. Okay, I have a problem. Because I know this is now 100. Should be right. X scale, Z scale. X scale is correct. Z scale should be correct. Z, alright. Let's keep this on top. I'm struggling a lot today. There we go. Come on, show me. That is correct. This should not be -5. Let's put a breakpoint in there. Figure out why. I hate having to debug like this. I think you can do conditional breakpoints, which actually makes more sense, and it's probably what I should be using, but can't remember how to set them up. I think you do like... I don't know how to do it. I can't remember. It's been a while. So let's start then. Z is equal to... Wait, no. That breakpoint didn't hit. I'm already at it, maybe. Come on, Unity. Yeah, I must be already at it, so that's why it's paused. Unity, what are you doing? This is not Unity. Alright, let's stop the debugger. What's going on up here? Unity. That's not what Unity looks like. There it is. Alright, stop. Do we have to recompile? Does it just do it itself? Whatever, I'm just going to assume it already has. Unity editor. Z. Next. Debug.log. Z scale should be O. O. That is correct. What I was probably looking at is this simplifying it. So if I go to verts, it might be rounding to 1. So if I go up to here, it should be 0.4. Yeah, it is. Alright, so that was actually working correctly the whole time. Alright, now to build the triangles. This is going to be a little bit more fun. So for int x equals 0, x is smaller than x total, -1. I'll explain that in a while. Actually, I'll explain that now. And probably same as that actually. Why am I repeating? You know what? I can index these without them even existing yet, so I can actually do this in the same loop. Because I already know their index, So I actually don't care if they don't exist yet. So what do I mean by that? Color paint. Because I know 0, 1, 2, 4 without the positions, I just don't care about the positions at all. I can go, where are we? Paint. 1, 2, 2, like that, and then like this. The reason why it's a -1 is because if you're on this pixel up here and try to draw up to this one, it doesn't exist. So that's why you have to skip both the top row and also the last, because this is also a failure. I don't exactly know how many triangles there is going to be. I suspect it'll be -1, z total -1. So if there's one triangle, it'll be, so if there's 1 point, there's 0 triangles, it's fine. If there's 2 points, so there'll be 2, 2, there'll be 1 triangle to draw. If there's 3 points, so that'll be 2 triangles, 2 triangles. Yep, I think that's correct. Alright. So, if z is under z total -1, and x is under x total -1, I'm going to put little brackets here because I like it too. Not that it really matters. Alright. So we're not up against the edges. We know that the next trial exists. So tries, current try, I can't be bothered actually keeping track of which triangle. Actually, no, I can work that out, can't I? Try index is equal to 2 times x Yep, that's correct. And then plus the y bit. So there will be 1, 2, so 4 plus 2 times the z, possibly? Times the x total? Minus 1? Just for sanity checking what we can do. We can calculate it, and then if we're wrong, then we can just say we're wrong. And stop here and have a look why we're wrong. Alright, so Karo's current try is equal to the x value plus 2 times that's just current try. No, it's not. Okay, hang on, give me a second. So 1, 2, 5, 6, 7, 8. Okay, 2, hang on. This is all minus 1. So 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, 6, 7. So . this will be this point here is just 2 times the length minus 1, and this point here is just 2 times x, or 2 times the length. Yeah, that's correct then. Yeah, I don't need to keep track of the current try. So yeah, 2 times x plus 2 times length minus 1, 2 times length. Yep, okay. Because try index. Oh, we want to map back the other way. We don't want to go from... No, we're right. Because we're in vertex... Oh, we already have the vertices from x and z. So try index. So we want to do x. So z times x total plus x. 1, 2, 3, 4, 5, 6. So x plus 1. So we're going clockwise, actually. So it's z plus 1. Z plus 1 total plus x plus 1. Then we're the same vertex. Wait, hang on. No. Because we're doing clockwise. X plus 1. This will be x. This line will be the same. Then this will be this line again. And then it would be plus 1 on both of them. Oh. I've messed up. So 0, 4, 1. 0, 4, 1. Just so you can see what I'm doing. 0, 4, 1. So 0, 4. Because that's... No. It's only z plus 1. So go up first. And then we go down to the left. Yep. And then this line's the same. Because we start back at that point. This bottom line's correct. And then we go back up to this point. So 0, 1, 2. No. 0, 1. Whatever. I'm pretty sure that's correct. Looking at that. So we're drawing... Because each vertex will give us a set of 2 triangles. So we draw them every triangle. Vertex 0, up 1, to the right, then here, then we go back up 1, and then we go here. Yep, that looks correct to me. We don't need this current try thing anymore. We know that's correct. And we know the amount of tries is equal to this, yes. Now if we were to build this, what would happen? I guess we can just try it. The alternative was create a whole heap of game objects, and that probably would have been easier code-wise, but I think it would have been such a problem having so many game objects for like every fucking square. So let's try and run it and see what happens. Are we right? Unity, you okay? Wow, how does anyone put up with Unity? This is slow as hell. And to be clear, this is not an infinite loop. Neither is this. We are so close if this is correct. The only thing that we're missing is some type of sampling function for the Y height. Let's have a look. It's having to think about it, isn't it? Did it really take that long to generate? Oh, I know what I've done. See a problem? Also, instead of using 100, we'll just use 10 just to make that go a lot faster. And we'll just make one of these squares. Unity's probably compiling. Yeah, there it goes. Well, it's wrong. Can we like do the thing where you like look around? The thing is, I'm in the game view. Oh, hang on. Yes, we can. So what's wrong with our triangles? I think looks like we're copying from this point all the time, which is probably what we're doing. Alright. Console, it's debug.log, triangle point. If we go back to 4, then my little display from before will work. Is this. This is taking me so long, holy moly. Not sure why that didn't autocomplete. Just draw one of the triangles. Print it out. X plus 1 plus 2. Okay. I'll come back here. So is this incorrect or is this correct? 0, 4, 1. We should see 1, 5, 2 somewhere. 0, 4, 1. 4, 8, 5. What? 12? Yeah, that's not right. draw my other triangle as well. 4, 3. Okay, so I've changed a little bit so I draw both triangles. Clear on play, please. I don't know if these are real messages or not. Okay, there we go. So 041, 145, that is correct. And the next one would be 152. Why do I have 485? This should be 152. Okay, so if I was correct with try-index, I think because it hasn't thrown, this is probably correct. This should just go 1, 2, 3, 4, 5, 6. I'm definitely drawing the wrong vertices. Come on, I know that's not my message. 0, 6, okay. Okay. This should just be 0. Oh, actually no, that's correct. Because it goes up by 6 each time. Because I've got 6 points, so 0, 6, 12, 2. 0, 2 times x plus 2 times z times what? All right, we'll do the trick. Let's call it test or whatever. Test plus 6. If try index is not equal to test, debug.log error. So my intention was to speed run this and do it under an hour. Currently I'm at like an hour 13. I don't think I'm too far off though. I just need to get my indexing correct. So my brain isn't working. Come on. Come on, Unity. Build on. Wait. What? I do have that breakpoint set. I'm very confused now. Because that should be breakpointing. So let's say the breakpoint again. Don't know why it wasn't there. Okay. 0, 6, 12, 2, 8, 14. This should have errored. If the try index is not equal to test. Is this even getting hit? Like, is this code compiled? Oh, well, I mean, it helps if you run the debugger. There we go. There we go. We have a problem now. This is what I wanted to see like half an hour ago. 0 is not equal to 6. Oh. This goes afterwards. Also, I just saw our compiler. It's here. Build. Specify which project, because there's more than one. Is there? Well, assembly C# probably. MS build assembly. Oh, terrain test. Terrain test dot selection. Did I forget how to use MS build? Wow, that is a lot of console there. MS build project file. MS build terrain test dot solution. That's what I should have seen. Oh, args. That's why. That's where I should put it. So now if I build it, that's what I want to see. Okay. So now that I can force the IDE to show me errors properly. And we have to turn on the debugger. Okay. Okay. Catch debugger, hit. So this should be the 2 line. 2 is not equal to 18, so this should equal 18. So z is 0, x is equal to 1. Test is equal to 18. 0, 1, 2, 3, 4, 5. Oh, 18. I think what they're meant to say there is 18 divided by 6 is our third triangle. So this should be equal to 3 in total. So this z component is nothing. Oh, it's 6. Because every time you go across a vertex, it's 6, another 6, another 6. And then every time you go up, it's 6 times the length. So now, helps if I restart. Come on. 18 is not equal to 6. So now we're on to the first one. Have I got test equals 0 somewhere? What? 0, 1, 18. How is test only equal to 6 if we're... Is Unity on drugs? That's not possible. Hey, well, I mean our squares there. I don't know why that errored. Let's do that again. I mean our squares there now, so that's good. Did that error? I don't think it did. I think that might have just been a compile issue, like I didn't recompile it. No, there is an error. Triangle 18. This is no way that this can just be 6. This had to get set somehow. Wait. Oh, I'm doing Z first. I'm not drawing crossways, I'm going upwards. So it's because I have these backwards. Alright, let's do that in the order that makes sense. Oh my god. This should be C total. Now I believe it's correct because the triangle drew correctly. So I suspect my indexing's correct, but I just went up instead of across. So my test thingo didn't work, even though it actually was drawing the correct triangles. Let's draw this. Did I break it? Did I break it? Oh, I see error there. Where is my script again? Let's attach, figure out why. So we have our debugger, plane 0, the mesh that generated. Did our mesh never get set? Let's check the console. Oh. That'll do it. That was funny. It was working. I just flipped it around, and it should have worked, but I missed. I missed something. Yeah, there we go. Goes back. So now we should see 0 for 1, 1 for 5, and then we should see 1, 5, 2 on the next line. 1, 4, 2. 041 and 145. And then that's 142, 2, 4, 6. What's the next line? So this will be vertex 5. So this will be next time 5, 8. Oh, 4, 8, 5. Yeah. Okay, that's correct. Well, anyway, we know it's right now, so we can go back up to our full 100, and then we can just add a function that sets our z height, and then we are done. Oh my god. Actually, let's just make sure that this works still. Hopefully the bug is there. I don't know if it will be though. Okay. Well, I mean, I guess I'm not debugging anymore because there's no errors. I don't think there's an error anymore. I think this arm just runs now without breakpointing. Yeah, there's the error. That's what I wanted to show. Although I thought there was only going to be a tiny gap. Huh? Can I like... Yeah, I can even select them. Cool. Alright, that's kind of cool. So there's our 5 planes that got generated. And they span from the 1, 1 and the mesh. So I don't need these triangle points. This is correct. This is correct. It generates the triangles correctly. Now the vertices. Oh, it's because it's 4. Now if we go back to 100. So 100 by 100 vertices per mesh. Which will take a little while to generate. You can see why people build stuff in lists. I just wanted to index it. There we go. Now, this is the bug that I wanted to show you. I knew this was in here from the start. See these little gaps? Hang on. Yeah, those little gaps there. They're there for a reason. That reason is in the code. And that code is this line right here. Because you can't draw to triangles that don't exist, how do I say that? Because this is only 100 wide, we're missing out. They don't overlap properly. It goes from 100 and then the next triangle starts on 101. So what you want to do is start, so you want to go all the way to 101. So, like, actually I probably wouldn't change these. What I would do is make it generate an extra. So smaller than or equal to. And then this line is just smaller than x total. So that draws our final triangle. So now this is no longer 100 wide, it's 101. Now, if we were to play that, would that error out? My indexing will be incorrect. Actually, you know what? We will... Yeah, we're going to put that back. No, these are 101. But we need to make it scale. Where's these x scale here? We do z minus the total minus 1 so that it overlaps. And this one here, z total and x total minus 1. So that way it'll go to 101. Now if we look at our Unity, hopefully, for this error, or would it be correct? Now if we look at it, our little gaps have gone, and this looks like just a single plane. Whee. Okay, so that's nice. Now that was the hard part. What's funny is that during this little this square thing, that looks like the easy part, but that's actually the hard part. The one final thing we are missing is some type of sampling function. So I'm going to start off with just some type of sine cosine stuff. So we will return a float, get height, float x, float z. And what we will do is we will say something like this. Return math f, I guess math f then, fine then. Don't want doubles. Thank you, Unity. We will do something like, let's just use sine waves. Sine wave of math.tau. What? Does tau not exist? Aww. Alright then. We'll fine then. 2 times math.pi times x. So that way every single unit it will do a cycle. And we will go plus mathf dot sine 2f times mathf dot pi times the frequency. So that there'll be some type of like, let's go 10. So it'll be really crazy in the z-axis. So if we were to generate that now, all we need to do is use, when we actually place our vertex, this 0 here will be get height x scale z scale. Now if you run it, the hard part easy and the easy part hard, right? We should see some type of wobbly terrain. Whoa, that looks crazy. And wrong, actually. What the? I think I've got a drawing problem there. I'm definitely not drawing my triangles properly, because from the top, am I still not drawing the triangles properly? I don't want to make them double-sided. I can see through them. I can't tell what exactly is going on there. Alright. Let's go down to 10. Oh. Oh, did I mess it up? I might have got my, the thing that fixed the gaps could have broke it. Oh. 2 math 5 times y. That's why I didn't look right. Okay, let's try that again. It's possible that I'm still not drawing my triangles correctly. Let's just go to do this. Let's go back to the one with gaps first. Let's draw one. Oh, no, keep drawing 5. What did I screw up? Oh, hang on. Did I screw up? That could have been 100 by 100, and then we just shift the mesh out a little so they match up. That's probably all I needed to do. Alright, I guess we can just have a look. I don't know if I've... What is going on? Doesn't help that my mesh is like just a solid color. I can't tell if that's correct or not. I can see that the frequency this way, if you look through it, it should be up and down 10 times second. Well, I mean, yeah, per 10 times per revolution. And I think it's just because it's just so high frequency data that the triangles look funny. Then in any case, I shouldn't be able to see them from the bottom, right? Okay. Why can we see them from the bottom? I thought Unity only draws them one way. Let's just return, like, X plus Y. So this should make it easy to spot. Yes, I don't care. I don't care. It's not reachable. It's fine. Oh, Z. So we should see like a sloped terrain now. What the F? So it should slope up. Yeah, so we can't see them from the bottom? Okay, good. So it slopes up in the X and the Y direction. Oh! That's why they're disconnected? Oh, that makes perfect sense. Because I haven't told them their total offset. Oh, here I was thinking I had triangle problems. No, it's this. So let's say this actually also takes a offset. So this will be a float. There'll be X offset, float, Y, Z offset. And here, X offset and Y offset, Z offset. That is going to mess me up forever. So now, yeah, I just had I couldn't see this before because of the really high frequency data of the math and the sign. Hey, hang on. Generate mesh I0. Oh wait, hang on. Are we offsetting in the... Yeah, we're offsetting in the x direction. So we build this again. Basically, I didn't tell it the height function, the offset of where the actual plane is. So now we have something that looks a lot healthier. So you see plane 1, 2, 3, 4, 5, and we look right up close to them and they all join. So that's cool, that's really cool. So now one last step is go back to our math sine function. And then let's draw this bigger. So let's draw like, I don't know, like 25 of these things. So let's start off in the Z. Start off in the X. So X and then Z. They'll get cast. I don't really care. Integers can go to floats. Fine. X, Z. X, Z. And then I think we will see some interesting stuff. And I'm going to actually slow this one down because 10 is probably going to be way too much. So we'll see it 4 times bumpy one way than the other way. So let's go Unity Editor. Don't think I need to... I'm so used to hitting that to run the program. Okay, play, and we should see... I think Unity's backing out there, but I think it generated. As long as I can't see through it and there's no gaps from the other side, this should all be... Oh, I think I'm seeing... I think that's actually okay. I think what I'm seeing there is... I should turn down the amplitude so I can actually see. So to do that, it's just this whole thing multiplied by some type of amplitude. Or like this. Let's say 0.1 times mathf plus 0.2. Oh, f. Oh my god, Unity loves those floats. Oh yeah, that should be correct. Loves their 32-bit values. Come on. Alright. That looks not too bad. The lighting is not so great. I can't really tell what's going on because the lighting is bad. But you can see that this way here is more amplitude, and this way here is less amplitude, but it's more frequency. So there we have a procedurally generated terrain. I think I'm going to stop here. Obviously, if you were to load this in the game engine, you could just doop, like, not disable them, but like you'll just delete the game object and then load them when you get close to them. So let's say like over here, like I didn't need to see this. I could just delete all of them and I could only be looking like this. And then when I turn around or something, I can come back and I can generate all that terrain again when I get close to it. So there you go. I guess for the lols, maybe everyone loves the Perlin noise function. So maybe I'll just add that in there as well. That's as simple as doing this. So let's just return mathf.perlinnoise xc. People in their Perlin function. And now if we stop that and start it. There is one thing with the Perlin function you should know. This is actually really worth pointing out. Oh my god, the lighting is so bad. Um, the one thing with the Perlin function that you should know is on, I think it's every... That actually looks not too bad. That actually looks fine. um, oh, it's just a blue blob though. Is there like a different material that doesn't suck? Can I like change these materials? I need to actually see the ground. The material is just terrible. Was this because it doesn't have normals? That might be a problem. Hey, hang on. Why can I see through that? I think Unity's having a spec attack. It's just like a solid blue blob. So yeah, I can't really see what's going on there. How about we use... What's this? Is there like... You know what? Is there a generate normals? Recalculate. Yeah, that probably helps. That'll make it stop looking like a blue blob. So I don't need a material. I think it's just I didn't have a normal map, so the lighting engine didn't know how to like make shadows. So if I start it now... Yeah! Look, now I can see! Alright. So one thing with the normal function, the Perlin noise function, is that I think on every single line... Is that actually a gap? Wait, what the hell? I can't tell what's going on there. I shouldn't be able to see it from the bottom. Don't know if that's a weird Unity rendering thing, or maybe my triangles aren't correct. Why? What's wrong with the... That could be a normal map problem, maybe. Doesn't know... Whatever. I'm pretty sure it's very... On one of these axes, it like always returns the same value. So when you sample the Perlin noise function, you should probably do it from within... Where is it? From within a 0 to 1 bound. So like if I divide this by 100, whatever the map is, it might actually just be flat now. I'm pretty sure the Perlin noise function, like on the integer values, returns nonsense basically, and it looks bad. Oh. Okay then. Okay then. So it is actually a pretty smooth function. I thought it was like infinite, like infinitely wild. Alright, I should probably stop messing around. I'll just put the Perlin noise function back. Get rid of that. Go back to this one. I want to see what this one looks like. With the actual normals, that makes sense. Oh. Well, that looks wrong. There is something seriously wrong with the lighting engine. And it looks like my normals... Very much well looks like my normals are all messed up. So,
I would expect to see the back side. So what the side we're seeing there when we're underneath is see these ridges that go up. Um, because like from straight down, the further away you get, it should just disappear. Yeah. What are we seeing when we come up close? What are we seeing? Oh yeah, okay, so there's a side that goes down and a side that goes up. We should be able to see the side that goes up. These. I don't know what this is. I don't know why we can see that. And I don't know why this looks so strange. Whatever. I mean, I think I'll just call it here. It must be... It's gotta be the lighting, right? Hmm. Oh well, whatever. I'm gonna stop it here, I think. And then, you guys can have a play. So I've got more to do, but I don't know. The point is that this is possible. You can generate planes, you can generate game objects, and you can have them match up by scaling the last Bizzo thing so that they... Oh, do they? Why does that look so strange? Huh. I don't know, some of the more Unity experience and meshes and stuff might be able to figure that one out. It could just be lighting, could be the normals being strange. Possibly because the edges don't know about this surface over here, so maybe the normals are like this way rather than up. No, it shouldn't matter. Shouldn't matter. Whatever. Alright. Have fun, everyone. See ya.